Good morning, friends. Today we will verify the Spark installation. In the previous video, we just installed Spark and Hadoop. So we'll just run some shell command for Apache Spark shell commands to verify that whether the Spark installation was good or not. So I will open the command prompt in admin mode first. So I've already opened it. And okay, so let me move to this and just expand it. So now, first of all, I will go to Spark home. So Spark home, we have already set this variable as the zip file that we extracted last time. I go to the bin folder here. So it moves to me to this Spark 3.1.bin Hadoop bin folder that we installed last time. So once we reach there by using the cd command, once again. So we are here. Let me type the dr command to see whatever we have here. So we can see we have got a Spark shell 2 command here. So I will select this, enter, and shift insert, and I will run this batch file. This is a CMD file. So what it will do is that it will launch the Spark shell 2 prompt where we can actually execute some Spark commands. So it's running right now. Sometimes it takes a little bit of time to actually run. So I will just try to fast forward it. So I have just fast forwarded it. So we can see that this command after running, it shows a lot of default values. For example, the default log level is 1. It starts the Spark version as 3.3.1. And the Spark context and Spark session. So Spark context is available as variable SC. Spark session variable is as Spark. And we can also see that our web UI is available at 4040 port as default. So Spark context and Spark session, these are two important concepts. Spark context is always one as per 1 JVM. There could be only one Spark context, but Spark session can be multiple. There can be multiple Spark session under 1 JVM. So now let's start writing some command here. So let's start with typing a Spark command. So by Spark, when I type the Spark here, it will, because it's a session, so we can see that Spark session is available as a Spark variable. So when again I put at Spark, so it means that I am trying to call the Spark session. So this you can see that the result is coming as Spark session, which is this type of object, which having. So this is the class name and the two. If we try the toString method, so it always the class name, full class path name at the rate of the hash code of it. So this is what by default the toString is created when I just print Spark. Now let's try to run some other commands. As we see that the Spark context is available as SC. So let's type SC command here. So again for SC we can see that by default it prints the toString method, which is the full class name at the rate of the hash code. The hash code is the memory address of this variable in our Java heap. Now let's, once we have printed this variable Spark and SC, which is already available by default in the command shell, now let's create a Spark RDD. Spark RDD, as we discussed in our third chapter 1, that RDDs are the resilient data structure, distributed data set, in which which are the basic data structures for Spark. So let's create it by using. So guys, I will be writing some Scala code here. So if you're not familiar with Scala, it's fine. I will be just typing very simple basic Scala commands to just show that how it works. So my RDD, I will create a variable like this, which is so val means that it's a constant, just like a final variable that we use in Java. Similarly, in Scala we use val. So val my RDD is equal to, I will use Spark. Spark is our session, so I will use this Spark session object dot Spark context dot parallelize. So parallelize is one of the ways that how we create an RDD. So what we did is that Spark, we took the Spark session variable, and then we referred from that session variable, we referred the Spark context, and then on that context, we call this parallelize method. And here I will call a sequence. Sequence is just like a list in Java. So in Scala, it's called as seq sequence. And I will just use 5.4.3, just like random integers. So we created a list of integers, and I will let me check whether the syntax is correct. Val minus my RDD is equal to spark context dot parallelize, and then we passed a sequence of integers of 5, 5, 4, 3, 2, 1. So once I press on enter, it should be able to create. So now my RDD is created. So we'll go into very details about this parallelize method, but just think about this, that it's used to create this RDD with having a sequence of integers from 5 to 1. And now this has been created. Now let's just simply print this. So my RDD dot for each, and I will just simply call println. So we are just passing this lambda, consumer lambda, and it's a very simple way to call this consumer lambda in Scala. So it will just print all these elements. So you can see that it's showing as stage 1. The output is not very well formatted, but we can see it's like 3, 4, 2, 1, 5. Because it's parallelized version, right? That's why it's not in the same sequence as we do in the array list in Java. So it's random, but it was able to print 3, 4, 2, 1, 5 here, all those 5. So this is an important concept that when we will discover again once we go deep into parallelized method. So this was all about the println method. Now let's count the number of partitions in RDD. Again, as we discussed in the theory part, that we have to see that how many, whenever we create an RDD, then Spark will create a number of partitions on that RDD, and then it will spread it across all the worker nodes based on the size of the data. Because the data that we're using is too small, so it will just take the default of the number of cores that we have. So for my laptop, I have got the number of cores is 4, CPU cores is 4. So I expect that by default, it will create the number of partitions to be 4. But I can check that by typing this command first. So get num partitions. Okay. We can also use a tab button, so it will automatically fill it. So for example, I just type this partitions and I press tab here. So it will automatically give the autocomplete feature is already available in this shell. So let's press enter here. So as mentioned, that because I've got 4 CPU cores, I'm getting this as 4. The number of partitions for this RDD is 4, which means that 4 partition has been created only for this small set of data of 5 integers. Now the next method that we are going to do is action parameter, which is a terminal operation. So again, it would be very simple. I can just use a dot operator and just type on count and just put on tab. So you can see that the auto feature is already giving me lots and lots of other options. So I just use a simple count, which is an action, or action means a terminal action. So I just put out count. So we can see that we have got 5 integers, right? So 5 integers are printed here. Let me go down again and type some more commands. I think it's good enough. I think just revise what we have done. So we moved to this bin folder where we have got our shell command. And once we run it, it will take some time, but it will show the basic version that we have installed. And also the Scala version, the Spark context variable name is SC. The Spark session is available at Spark. And also we have got the Spark default web UI available at 4040. So if I, before closing this, I will also show this this web UI that we have created, which will also show that how we can access or monitor our Spark. Because our Spark is already running, we haven't quit this session, so this session should be already available. So I'll go to my this Chrome here. So the default web UI is available at, I will just type HTTP localhost 4040. 404 is the web UI, and this will come to this page. And you can see that we have actually run few commands here like for each and get num partitions and count, etc. So we can see that here it's actually showing me that count was run at this particular job ID and for each was run and what time it was submitted. And there are a lot of things that we have to discuss here, which we will go into details when I cover the monitoring part. So just think about this, that this is the web UI which is available, and because our shell is still alive, it is not exited yet. So that's why we can see all these type of jobs and all. And if I just go to the stages, it will give me the stages that it has been run. And storage, there are a lot of things that we can monitor from here. Environment and executors as well. Executors are those processes which are running on the nodes, worker nodes. You can see that there are so many matrices that we can see and monitor. So this was about the Scala and the very basic like commands, or you can see that we can type a lot of like commands from the Spark shell. But from the next videos, we'll start writing actually Java code when we set up our IntelliJ project. So let's finish this shell prompt by just typing this quit command. So the way it is done is that we had to colon quit, and then we have quit, and then I will do an exit here. Once this is all done, so we have verified our Spark installation on the Spark shell itself. So guys, this was all about the Spark installation verification that we did by typing some commands on the Spark shell. In the next video, we'll start working on setting up our IntelliJ project, the Maven project, because this tutorial series is on Java, and we will write all those like Java unit test cases and programs on Apache Spark. And we'll start that by setting up our project first. So see you all in the next video.